All right, now we're going to talk about sketching a graph. So we have some information here in our first problem, and we're going to look at how to make a graph to match this problem. So let's start by looking at the information. It says Kim measured her pulse rate during a 45-minute workout. So we know the workout lasts 45 minutes. And the workout includes a 10-minute warm-up period and a 10-minute cool-down period. And so we need to sketch and label a graph showing her pulse rate during her workout. So what we're going to be looking at here is her pulse rate and then time. And whenever you're making a graph and time is included, time is always going to go on the x-axis, and we are always going to be doing a line graph. Okay. Now we don't need to have numbers on the y-axis because it doesn't tell us what her pulse rate is. We're going to make some logical assumptions about her pulse rate. So first off, this is going to be pulse rate. Okay. And then here, down here, I'm going to have the time, and it's going to be in minutes. Okay. And we know it's a 45-minute workout, so I'm going to go ahead and I'm going to mark 0, 10, 20, 30, oh, I'm almost going to run out of the room here, 40, we'll just extend this a little bit, we'll put 50 about right here. So I'm trying to make equal intervals, of course, and now let's draw a line to show what her pulse rate would look like. So we know that she has this 10-minute warm-up, and then she has a 10-minute cool down, and we're going to assume that she's doing like a steady workout. She's not doing intervals or something like that. So where are we going to start out on her pulse rate? Not at 0, right? Because she's not dead. She has a pulse. Like right now you have a pulse just sitting there. So she's going to start at some amount, and she's warming up for 10 minutes. So we would expect to see that for like first, she's going to start out at just a normal pulse rate, but then it's going to kind of slowly increase until we hit the 10-minute mark, okay? Or it's going to increase until we hit the 10-minute mark. Maybe she's working out more intense than that. I don't really like the line. We're going to go like this, okay? And then she's going to work out for 45 minutes total, so we know we've got to end here. We're going to assume she cools down to about the same point, and if it's 45 minutes, then we've got to have that from 35 to 45 is going to be her cool down. So this is going to be like her period of cool down. So then in the middle here, she's going to have this steady pulse rate. So her heart rate is going to stay the same for that duration of the workout. Okay, so we would show it increasing during the warm-up and then staying steady for the duration of her workout and then decreasing during her cool down. So we're taking the information from the graph and we are setting up the graph. Sorry, we're taking the information from the problem and we're setting up the graph first off, and then we're drawing the line to match the graph, to match the data. My goodness. All right, let's look at the next one. Okay, we're walking to a friend's house. For the first 10 minutes, so right away time, so I know time's going on the bottom. For the first 10 minutes, you walk from home to a park. For the next 5 minutes, you watch a game at the park. And then for the last 5 minutes, you run to your friend's house. So those are the 3 things that I noticed. You're walking, you're watching, and then you're running, okay? And now we need to sketch and label a graph showing your distance from home during your trip. So my x-axis is again going to be time. And it's going to be in minutes, okay? And what's going to go on the y-axis here? What's going to go on the y-axis here? It's going to be our distance from home. And concerned with numbering that because it doesn't tell us how far you get from home. We do need to label the time here, and it looks like we're working in increments of 5. So 0, 5, there's 10 minutes, there's 15 minutes, and there's 20 minutes. I know I only need to go to 20 minutes because if I am walking for 10, watching for 10, 5, running for 5, that makes 20 together. So I start out. So here's home, right? Right there. And my friend's house is going to be up here somewhere. So I'm 10 minutes, I'm walking from home to a park. Then I would expect to see my distance from home increasing at like a steady rate. So I'm going to go from here to here. And maybe I'm going to go like that. Like I'm walking at a steady pace. Straight edges would probably be good here. Then if you are watching a game for 5 minutes, what's happening to your distance? So you walked to the park, and then you stop and you watch a game. Your distance is going to stay the same, right? It's not going to increase at all. So for those 5 minutes, you're just standing there. Then you realize, oh man, I got to get to my friend's house. And so you start running to your friend's house. Well, here you're walking, so it's kind of a gentle. When you start running, the line's going to increase more drastically like that. And so you're going to be covering more distance for that time. And so that is how you sketch a graph from data in a problem.